Picture a sky so powerful and unpredictable that it can transform into 5 distinct tornado monsters, each with its own unique fury. Tornadoes are among nature's most terrifying atmospheric phenomena, capable of reshaping landscapes and altering lives in moments. Their sudden appearance and immense strength have fascinated and frightened people for centuries. In this section, we delve into the mysteries of tornadoes, exploring how they form, what makes them so dangerous, and why they continue to captivate our imagination. Prepare to uncover the secrets behind these swirling giants and learn what sets each type apart in the world of extreme weather. Contrary to popular belief, tornadoes come in a remarkable variety of forms. While many imagine a classic funnel stretching from the sky to the ground, some tornadoes are nearly invisible, cloaked by dust or rain, making them difficult to spot until it's too late. Others can form horizontally, twisting along the ground, rather than reaching down from the clouds. These unusual types challenge our understanding and reveal just how complex tornado behavior can be. As we delve deeper, we'll uncover more scientific mysteries that continue to puzzle researchers and reshape our knowledge of these powerful storms. Multiple vortex tornadoes are a remarkable and powerful phenomenon in severe weather. Unlike a single continuous funnel, these tornadoes contain several smaller, rapidly rotating subvortices within the main circulation. Each subvortex can spin faster than the parent tornado, intensifying the destructive potential. As these sub-tornadoes sweep across the landscape, they can create highly uneven patterns of damage. It's not uncommon for one building to be completely destroyed, while another, just a short distance away, remains untouched. This unpredictable nature makes multiple vortex tornadoes especially dangerous and challenging to study. Their complex structure continues to intrigue meteorologists and storm chasers alike. The wedge tornado stands out as the largest and most formidable type of tornado, with widths that can exceed a mile. These massive formations often appear as broad, dark clouds on the horizon, making them difficult to distinguish from regular thunderstorms at first glance. Their sheer size and indistinct shape can lead to underestimating the threat they pose. Once a wedge tornado touches down, its destructive capabilities quickly become apparent, capable of leveling structures and reshaping entire landscapes. Meteorologists pay close attention to these tornadoes due to their potential for widespread damage and danger. Landspouts are a unique type of tornado that differ from the more familiar, powerful twisters associated with severe thunderstorms. Unlike traditional tornadoes, landspouts form from the ground up and do not require large, organized storm systems to develop. Their slender, rope-like appearance can make them seem less threatening, but they can still pose significant dangers. What makes landspouts particularly surprising is their tendency to appear suddenly, even on days that seem relatively calm and uneventful. Because they are not linked to massive storms, they often catch people off guard, increasing the risk of injury or damage. Understanding how landspouts form and recognizing their potential hazards is important for staying safe during unexpected weather events. Waterspouts are tornadoes that develop over bodies of water rather than land. Typically, they are less intense than their land-based counterparts, but their swirling winds are still powerful enough to lift small boats and hurl debris across the surface. Waterspouts can pose significant risks to those on or near the water, especially when they approach populated areas. If a waterspout moves ashore, it can transform into a traditional tornado, bringing its hazardous conditions onto land. Despite their often picturesque appearance, Waterspouts should be treated with caution due to their unpredictable nature and potential for danger. Gust tornadoes are short-lived, chaotic whirlwinds that develop along the leading edge of gust fronts, which are boundaries created by outflowing air from thunderstorms. Unlike true tornadoes, gust tornadoes do not form from the storm's main updraft and lack the organized structure of a tornado. Despite this distinction, gust tornadoes can produce strong, swirling winds capable of causing notable damage to property and vegetation. Their appearance is often sudden and brief, making them difficult to predict or track. While they may look dramatic, gust tornadoes are generally less intense than tornadoes, but their impact should not be underestimated. Understanding the difference between gust tornadoes and tornadoes helps clarify the risks associated with severe weather events. Experts at the National Severe Storms Laboratory, along with meteorologist Dr. Harold Brooks, highlight the remarkable variability of tornadoes. Tornadoes can differ greatly in size, shape, and intensity, often changing rapidly as atmospheric conditions shift. Factors such as temperature, humidity, and wind patterns play crucial roles in determining how a tornado forms and evolves. Sometimes, a tornado may begin as a narrow funnel and quickly expand into a wide, wedge-shaped column. These transformations can occur within minutes, making tornadoes unpredictable and challenging to study. Understanding these dynamic processes is essential for improving forecasting and public safety. NOAA research has revealed the existence of invisible tornadoes, often referred to as clear air vortices. Unlike typical tornadoes, these phenomena lack the visible funnel cloud, making them nearly impossible to detect with the naked eye. They only become noticeable when they begin to lift dust, debris, or other materials from the ground. The absence of condensation in the vortex is what makes these tornadoes so elusive. Meteorologists rely on radar and other advanced technologies to identify their presence, but even then, detection can be challenging. This explains why some tornadoes seem to appear suddenly and without warning, posing unique risks to people and property. Tornadoes are typically known for their powerful cyclonic rotation, most often spinning in a counterclockwise direction in the northern hemisphere. However, on rare occasions, scientists have observed tornadoes that rotate in the opposite or clockwise direction. This unusual phenomenon, known as anticyclonic tornadoes, challenges our conventional understanding of how tornadoes form. The causes are complex, often linked to unique atmospheric conditions, such as wind shear and the interaction of multiple storm cells. Studying these backward-spinning tornadoes provides valuable insights into the dynamics of severe weather. By understanding what triggers their formation, meteorologists can refine forecasting models and potentially improve early warning systems. Ultimately, these rare events remind us that the atmosphere still holds many secrets waiting to be uncovered. Tornadoes manifest in a wide array of shapes and sizes, each with its own level of intensity and destructive potential. From slender ropes twisting across open fields to massive wedges that can flatten entire communities, their unpredictable nature makes them both fascinating and fearsome. The diversity in their formation and behavior continues to challenge scientists and captivate the public. In the next part of this series, we will follow storm chasers as they venture into the heart of these violent storms. Their relentless pursuit aims to unravel the mysteries behind the most powerful winds on Earth, offering new insights into the forces that shape our weather.